Hello, this is Glenn Broderick from Vitrek, and today we're going to look at how to use multiple power analyzers as part of an integrated system. Now, this presentation assumes that you've already been using the power analyzers a bit, or at least seen some of the other videos about how to run them, so you know some of the basics, because we're not going to cover the basics here. But bottom line is that sometimes you can buy a power analyzer, and then if you decide you need more channels, you can just get another analyzer and just connect them together, and it all works as one integrated system. We can use 2 or 3 analyzers together to get 12 channels, programmatically, perhaps even more. So what we're going to do here, before we start, we want to talk over a little background information so we understand the concepts, and then we're going to show you a demo of how this works. To begin with sampling rate, I'm sure you're familiar with sampling rate. It is very much like an oscilloscope. Sampling rate's important. Most oscilloscopes are 8, 10, or 12 bits. These power analyzers are 22 to 24 bits, so they're a lot higher resolution devices. Each analyzer has 4 slots. We make multiple cards that can go in each slot, but each card has different capabilities, and you need to keep that in mind so that you have the right card for the test you want to do. Every card has a different sample rate and bandwidth. The base card is 245 kilosamples a second and a bandwidth of 700 kilohertz. But we have faster cards if you need them, going up to 1.2 megasamples a second and a bandwidth of 5 megahertz. So just as a oscilloscope can be a real-time oscilloscope or a sampling oscilloscope, we basically have both capabilities as well. So we can have a 1.2 megasample per second, that's real-time sampling rate, but we can also do time equivalent sampling up to 384 megasamples a second, and that's handy whenever you're dealing with repetitive signals. Now, we also have another parameter which is different from sampling rate called measurement rate. So to us, a measurement, we make these in order to handle large volumes of data, and we take all the samples and then we add them all up and calculate the maximum value, the minimum value, and the mean. And what this means is it acts as a data compression algorithm, so you have less data to transfer across buses or to save. In fact, our data logger can run very, very long weeks, months tests where other people run out of time like after 90 minutes. And it's because of this data compression that we use. And the nice thing about it is, since we have the max and min value, if there's any transient within our sample speed, we'll still find it and we'll still record it. Now, the measurement rate can be adjusted for the speed of the signal you're analyzing, up to 500 measurements per second on the PA920 or 150 measurements per second on the PA900. The sample rate, in contrast, always runs at full speed all the time. We never slow down. So you always have full resolution on the samples. Now, we also use a concept called a virtual power analyzer. And the virtual power analyzer, I like to think of it as a group. So we're able to group channels into a virtual power analyzer. It also makes this one analyzer act as 3 separate analyzers. So one common use is, if you're doing 3-phase power, you can put 3 channels into one VPA, and so now you can look at each channel individually, channel 1, 2, or 3, or you can look at the aggregate for the 3-phase power by just looking at the VPA stats. Now, one of the applications is you can use one VPA and label it input and one VPA and label it output, and then we can measure the efficiency between the input and output. In fact, we can do that between 3 different points, so a little bit better than that. Now, synchronizing units. What does it mean to synchronize the unit? If you need more than 4 channels for a test, you can use Ethernet to synchronize 2 or 3 chassis. This is handy when you have a system where the input's a great distance away from the output. So you can connect this over the internet, and you could have one looking at the power generator in one part of the state, and you could have another looking at the load in a different part of the state. Synchronization does not mean synchronizing the samples. They're running as fast as they can all the time. Too fast to synchronize with Ethernet. but the measurements are synchronized. That's what counts. So when we synchronize the measurement period, the measurement start and stop, the measurements themselves, the integration start and stop, the history start and stop, and also the configuration. So all of those make this really handy for using as a distributed system. Now, there are two ways of doing it. We have two approaches, one called multi-VPA and the other is sync VPA. And so the question is, which one do I use and when? Okay, for most applications, you want to use the multi-VPA. And what that does is it syncs everything except for the measurements, okay? But the advantage of the multi-VPA is it's steady with almost no jitter between any of the measurements. So if jitter is an issue to you, use multi-VPA. And in fact, the multi-VPA works for almost all applications unless you happen to have a signal that's changing power often and a lot, or maybe even ripple on a DC supply. But even then it probably works if you just set the measurement rate fast enough, okay? But if you really want all your measurements to be exactly synced, then use the sync VPA. And what that does is it basically makes the measurements, and then it asks everyone if they're all ready. When they're all ready, then it'll make the measurement again. So it's going to be a little slower. There could be a little delay between the measurements while it's waiting for a response on Ethernet, but that will sync all your measurements exactly. Okay. Now, this is the steps of how to go about setting up several units and using them as multi-unit systems. And we're going to go in and do a demo of these steps and show you how they work.
Okay, I've set up two power analyzers, one on top of the other, and I'm just going to follow through the steps I showed you on that last slide. So the first thing you do is you go to the measurement config, that's right here, and on the top menu select measurement mode, and choose either multi VPA or sync VPA. For this case, I'm going to choose sync VPA because I'm going to show you the measurements being synced, and that's all you got to do. Next thing, enter the channels into this VPA as desired. So right here you can see we're set up for configuring VPA 1. I can select over to VPA 1, 2, or 3 as desired. I'm just going to use one VPA. And like an oscilloscope, I can come over and I can turn channels on and off just by doing that. So let's say I want to put a couple of channels into my VPA 1. I'll do that there. I'm on VPA 1 here as well, and here I've got a couple of channels already put into the VPA. Now I've connected the units with the Ethernet cable. If you have 3 units, I don't know if you've noticed, but cables have 2 ends. So what you'll need is an Ethernet switch and 3 Ethernet cables, but you can connect them all together with an Ethernet switch. Now on each analyzer, select the interface button. This is the interface button right here, and select, actually they're already selected to LAN, but let's say if one had been on USB and one had been on RS-232, we'll start kind of fresh, okay? So what you do is you go in and say, okay, I want to use LAN, and then the next button down is how you want to address it. Okay, so I can put in a static IP, or if I've got DHCP connected on my LAN somewhere and I've got access to it, I can use that. Or I can use auto IP. Auto IP works if you have 2 units. It allows them to negotiate together and they come up with an address. Otherwise use static IP and DHCP. So let's do that on both. Auto IP, good. Now when you're done, down here it should say LAN. In this case it says sync VPA. Or before it would have said multi-user VPA. Okay. So now once that's done, it's really all synced. You just want to prove that it's synced. And one way of doing that is to go to the history. And I basically can just tell it to stop. And you notice it's stopped on both units because they're synced. Or I can tell it to start. And notice it doesn't matter which side I run that from, because there is no master slave. The interface, I can use either interface for running the units. So that's really all there is to it, and I wish you good luck on your testing. And you can see that only took 3 minutes to set up.